All right, guys, we are gonna keep going 9.3. Did we finish letter M on number 2? Should we do that really quick? Okay, it's one of our card problems. So we got some card problems, we got some Venn diagrams, and we got one more probability tree. Kind of everything that I can wrap up today, we're gonna wrap up in this 9.3. Okay. So we did some cards the other day. It was a bonus on our quiz. We are gonna need to go over it a little bit more before our test, but I just wanted to do that one last problem. It says, what's the probability of being dealt 2 of one suit and 3 of another? Okay. Remind me, what are the suits? What counts as a suit?
Jacks.
Those aren't suits.
Spades.
Diamonds, aces, clubs, hearts. Okay, good. All right, so those things. So I'm gonna make it up. So let's say we're gonna get 2 of hearts, 2 hearts, okay? What's my probability, or what's my how do we write that we want 2 of the hearts? How many total hearts are there? And how many do I want? Good, so we're gonna do 13C2. Now let's say we're gonna do 3 diamonds. That's a funky diamond, but just let it be. What's how do we write if we want 3 diamonds? 13C3. And then if we want to make it probability, what's the total number of hands? 52C5. Awesome. Now, we're not done yet. There's going to be something that goes in front of this, all of this fraction, okay? You know how when we said 2 of one suit and 3 of another, I just said, okay, let's pretend it's 2 hearts and 3 diamonds. What if it was 2 spades and 3 hearts? We don't know, but it does matter, okay? So remind me, if I'm going to be picking these suits, when I picked hearts, how many did I have to choose from? How many suits did I have? 4. There are 4 suits that I chose from, and then I picked one. And then when I decided the next one was diamonds, how many did I have to choose from to pick diamonds? 3. So we're basically doing 4 times 3 on the outside. Or if you remember, that's the same thing as doing 4P2. Why is it P, not C? Because it matters. If I said I want 2 hearts and 3 diamonds, is that different than saying I want 2 diamonds and 3 hearts? Yeah, it matters which one goes first because I only want 2 of one and 3 of the other. So that's why it's a P, because the order matters. When we're doing other things with cards, it doesn't matter the order because again, you're going to get it in your hand and you're going to kind of shuffle them all up. But when we are doing 2 of one suit, 3 of another, that matters. So we're going to do P. Yes.
What is the 4 and the 2?
The 4 and the 2 is how many suits there are. So 4 suits. And then we want 2 of them. So we're picking a first suit that we want 2 cards, 3 of another. So there are 4 total suits, we want 2 of them. I hate to keep skipping around, and you're gonna find this really annoying, but I want you to just get back to the probability trees. I don't think we finished letter C, and we definitely didn't do letter B. Go look at your letter C. What's empty there? What do we need to finish up on letter C right here? Did we do it all? So we just need to multiply it out. Yeah, okay. So I think you guys have, I think you have the chart done. I think you've got all of that figured out. I think what we don't have is us multiplying it out. We have our past taken, so I'm going to do 0.7 times 0.62. I can find a calculator.
No, I had it for a subject for German class, and I was telling him how we could really hear him preaching about that.
What did you say?
He said, I get a little excited sometimes.
Well, sometimes I get nervous that he's like mad and like yelling, and I'm like, that's not good. But I think he's just always excited. So I love that for him, but because we have to be okay if they don't play soccer, but yes, they play lacrosse. So that's 0.578, which is 57.8%. Okay. Everybody good with that one? Did we finish that? So here you lost. Keep going. We're looking at number 10. Good. Yep, we like skipped a bunch of pages. We're gonna go back and do those Venn diagrams in a second. Yep, right there. All right, that, I think I'm done on that one. So 57.8% chance that this student plays lacrosse. Okay. Now we're gonna do the middle one. The reason I skipped that one is I feel like it was a little bit less implied what was like the cause and what was the effect. So it says if the cafeteria serves noodles, then there's an 80% chance that they will serve salad. If they don't serve noodles, there's just a 50% chance they'll serve salad. Given that they serve noodles just once every school week, find the probability that they will serve salad. Okay, so let me tell you what order it's in, and then I want you to fill in with all the probabilities and try and solve it on your own. It says, given that they serve noodles, that means that noodles goes first. So the first part of my Venn diagram goes yes, noodles, and no noodles. From there, we care about salad, so then I'll have a yes salad, and I'll have a no salad. And with no noodles, I'll have the same thing. I'll have a yes salad and I'll have a no salad. So I'm gonna be quiet. I want you to fill in the probabilities just like we did on the last couple. You guys ready to help me get some percentages? What's the percentage that they'll serve noodles in the cafeteria? Ooh, where'd 0.2 come from, Sophia?
That's 5, and then 5.
Good, if they serve once every school week, that's 1 out of 5, and that's 20%. So that 1 out of 5 goes, is how we got that 0.2. So then what's the probability they won't serve noodles? 0.8. Now we'll go back to our noodle train and we'll go, okay, if they serve noodles, what's the percentage they'll serve salads? 0.8. What's the percentage then that they won't have salads? 0.7. What about if we don't have noodles, what's the probability we will have salad? 0.5. And then, so then no salad would also be 0.5. Everybody doing okay so far? Now we want to take as many paths as we can to end at salad, okay? So I'm gonna start yes noodles, yes salad, that's a path to get to salad. I don't want to go to the no salad, so now I'm gonna go no noodles and then yes salad. And then those are my only 2 paths. We need both of those things to happen. We get noodles and we get salad, or we get no noodles and we get salad. So we multiply those 2 together. So we'll do 0.2 times 0.8. And then we'll do plus, and then we'll do 0.8 times 0.5. And so that gives us 56% chance that we'll have salad in the cafeteria. All right, are we doing okay with probability trees? Okay, again, I'm so sorry we're skipping around. Go back to the beginning of the Venn diagrams. We are not gonna do problem number 8, so you can just cross that out or you can ignore it, but we are gonna do 5, 6, and 7. Now, the page that has a lot of Venn diagrams looks like it's gonna take a lot longer than it is, but I promise it goes pretty quick. You guys have seen Venn diagrams before, right? I'm not the first person teaching you this, right? Okay. So like, let's see what does this mean, okay? So I have got this Venn diagram. It says that there are 30 students in this class. So tell me, how many students like M&Ms?
17.
Okay, I heard a change of answers and we decided on 17. Why is it 17?
The one in those 2, yeah.
Good. Everyone who's in the M&M circle counts. So everybody in here counts as M&M likers. They like M&Ms. Okay, what about, how many only like M and M's? That's where my 11 comes from. So if it's not in the like overlapping part, that means they only like M and M's. Okay. How many like M and M's and Twix? 6, that's the one in the very middle, okay? So we don't want to. We only want the ones that like both of them together, and so the both of them together is right here in the middle, and that is my 6. How many like M and M's or Twixes? We're gonna go a little bit, let's see. Okay, let's compare letter D and E. It says how many like M and M's or Twix, and then how many like only M and M's or only Twix. So I like 20 for the second answer. Where does 20 come from that like only M and M's or only Twixes? That's 11 and 9. So I like 11 plus 9 gives us 20. That's how many like only M and M's and only Twixes. How many like M and M's or Twixes? How many, if I filled my candy jar up with M and M's and Twixes, would be happy? Not necessarily everybody. 26. Where'd you get 26, Sydney? Good, we have to include the ones that like both. So if I had M and M's and Twix in my candy jar, anyone who liked both would be happy because they could have one or the other. And whoever liked only M and M's would have that only M and M's, and who only liked Twix would only like Twix. So that one is 26. So we gotta include everything in all of the circles. Now, the reason I said it, you can't assume it's everybody because it says how many like neither candy? 4. So once we decided that only 26 kids were counted for in my 30-person class, there are 4 kids who do not like M and M's or Twix. So if I only had M and M's and Twix, they would be sad because maybe they wanted Jolly Ranchers. Who knows what they want? Okay, we doing okay with that Venn diagram? Okay, let's look at the next one. Each of 26 students in a class either likes jazz music, country music, or both. Okay, it is important to note that it says each of them either likes jazz, country, or both, which means that there are none that like neither. So none of them like neither. Okay, let's figure out how to fill this in. If 0 like neither, I can put a little 0 out in that corner so that I know that all 28 kids should be on the inside in here. It says 18 students like jazz, 14 students like country. Okay. How many total kids or how many total like votes is that? 32. Okay. And do I have 32 kids? How many kids voted twice? Where'd you get 4 from? 32 minus 28 is 4. So if I have 18 and 14, then that means 32 hands were raised, which means 4 of them raised it twice. So 4 is in the middle. How many is only jazz? Well, 18 students like jazz. So 18 students are in my like jazz bucket. So how many like only jazz? Subtract 4. So I'm gonna subtract 4 from 18 to figure out how many like only jazz. So that's 14. And then I'll need to do it from both because we also want to know how many only like country. So 14 minus 4 is just 10. And if I did 14 plus 4 plus 10, is that 28? Perfect. So my question was how many like only jazz, and what number did we say that was? 14 students. Yeah, I told you it was a little fast. The next page is gonna be a little bit longer because now we're not just gonna have 2 circles, we're gonna have 3 circles in our Venn diagram. So go ahead and flip your paper over. This is the last 2 examples that we're doing. I feel like there's one like this on your homework, so I wanted to make sure that we got to it. Okay. It says a class of 32 students is surveyed as the type of car they like. 19 like Ford, 19 like Buicks, and 12 like Chevy. Okay. We have information about Fords, we have information about Buicks, and we have information about Chevys, okay? Which means that I've got 3 circles that I'm gonna fill. So I'm gonna make a Venn diagram, and you can put it wherever you want. You can put it above. I'll probably just put it right here in the middle. And I've got a circle for Fords, or I like kind of doing an oval. It helps me overlap them a little bit better. I've got an oval for Fords. I've got an oval for Buicks. And then I've got an oval for Chevy. Ford, Buick, Chevy. My shapes don't look great, as long as you have like 3 circular oval like shapes, we can put numbers in them, that's all that really matters. Okay, the first number is the most important, it says 5 like all 3, where does that 5 go? In the very, very middle, right? Then it says 6 like only Fords. So in my Ford box, we're gonna put 6. Where am I gonna put that 6? We're gonna kind of put it like the highest part where it's not overlapping anything. So the part of the circle that's not overlapping or touching anything else. Then it says that, oh, 3 like only Buick. So if I look at my Buick, ooh, that's. If I look at my Buick circle, I'm gonna put again 3 where there is no other touching with the other numbers or letters. And then last, it says 2 like only Chevys. So again, I'm gonna look at my little circle and I'm gonna put 2 where it's not touching any other color. Now, there's a lot of holes on my graph that I don't know how to fill. I've got 3 little blank spots. Do you see those 3 blank spots? Okay, we're gonna label them X and Y and Z. And you could label them differently than me, so if you wanna make sure that you get the exact same answer that I do and not in a different order, make sure your X and Y and Z are in the same spot as mine. We're gonna bring in some knowledge from our last unit, from our matrices in order to solve this, okay? So let's look at the green circle alone, okay? If I look at that green circle alone, those are all the people, bless you, who like Fords. How many did I tell you at the beginning of the problem like Fords? 19. So all 4 of these numbers together add up to 19. 6 plus 5 plus X plus Y all adds up to 19. So we're gonna write an equation like that. 6 plus 5 plus X plus Y equals 19. We're gonna write all of our equations and then we'll start simplifying. Okay, we can do the same thing for Buicks. How many did they say like Buicks? 19 again. So we're gonna do 3 plus 5 plus Y plus Z this time. And then last but not least, we'll do our Chevy. And how many people total like Chevy? 12. So we'll do 2 plus 5 plus X plus Z equals 12. Okay. Okay, before we do anything, let's simplify those expressions, those equations, okay? So the first one, I can combine 6 and 5 to be 11. So now I've got X plus Y equals, what's 19 minus 11? 8. So I wanted to move all my constants to one side. I minus 11 from 19, I got 8. Similar idea for the next one. Okay, 3 plus 5 plus Y plus Z equals 19. Well, we can add 3 and 5 together, and that equals 8. So we'll minus that from both sides. So now I've got Y plus Z equals 11. All right, and then my last one, I've got 2 plus 5 plus X plus Z equals 12. So 2 plus 5 is 7. When I minus 7 from both sides, I get 5. So I get X plus Z equals 5. Okay. Now, I know I kind of set the equations up kind of funny, but do you see what I'm getting at when I set them up like this? This is a big systems of equations, isn't it? Do you remember the whole last unit, we were solving systems using matrices? Do you think that there's a method that we could use to solve this system? What's our favorite way to solve matrices? RREF. Could we make this an augmented matrix and then do RREF of it? Yeah. Why not, right? Let's do it. So I'm gonna set my augmented matrix up so I get 1, 0, 1, 1, 1, 0, 0, 1, 1, and then I have 8, 11, and 5. Once I have my augmented matrix written, I'm gonna put it in my calculator, I'm gonna do RREF of it. Once you know it's right, clear out, do our RREF of it. And so now, what is my X gonna be? What am I gonna replace X with in my Venn diagram? 1. What's my Y gonna be? And what's my Z gonna be? Perfect. So instead of having to solve that out, we've got all of our numbers and we're gonna use that to figure out what the probability of the questions that they asked us. So I'm gonna go back to my picture. And again, you have to remember where your X, Y, and Z were because it's easy to just fill in the wrong numbers in the wrong blanks. So my X was 1, my Y was 7. And my Z was 4. Everybody doing okay so far? Okay.
Or you did the RREF, how did you know like what the 1 zeros were?
Oh, they're based on the equation up here. So like my first column is my X's coefficients.
Yeah.
And then my second column is my Y's. You good with that now?
Yeah.
Okay, now using my picture, it says, what's the probability that a student chosen at random likes both Chevys and Buicks? Okay, so we want to see where Chevys and Buicks overlap. Where do they touch? They touch at 5 and 4. So that means that how many total students like Chevys and Buicks? 9. So 5 plus 4 is 9. And how many total students are in this class? 32. So 9 over 32. I am happy to just leave it as that fraction. If you would like to make it a decimal, you are welcome to. 9 divided by 32. It's about 28%. The next one said, what's the probability that a student likes none of these cars? Oh, add them all up and minus from 32. So I see 6 plus 1 plus 5 plus 7 is 19. Plus 3 and 4 is 7, plus another 2 is 28. So how many kids have we not counted? 4. So how many kids like none of the cars? 4 out of, good. And you can leave it as 4 out of 32, you can break it down to 1/8, you can make it a decimal. 12.5%. Let's see if we can do the next problem. Do you think you can try and set it up on your own? Okay, see if you can set it up on your own. I'm gonna try and do it silently up here, so you can still see it without me talking you through it. I have mine set up. I also have my X, Y, and Z in place, so if you wanna make sure that yours match what mine is, so that when we put it, in our equation, that you have the same thing that I do. Again, you don't have to, you'll find the same pieces, just maybe a different order than I do, if you don't have the same X label that I do. I've got my X, Y, and Z on the board. Oh, that can't be right. Wait a second. Oh, I think I added wrong.
Yeah.
It should be 22, not 32. I was really convicted until I realized it was -2 students, and I realized that can't happen. So it should be 22, not 32. This is the number I should have gotten. I'm just not gonna go back and plug it in. 12 and 10 and 3. Is that what you guys got for X, Y, and Z? Oh, and 10 and 3. All right, we don't have time to finish to figure out what's the probability that one student will like at least one color, but we can wrap it up quickly tomorrow, okay? The second homework of 9-3 is due next class, which I believe is tomorrow. Tomorrow's the day 3, I think. So do that second sheet of 9.3 for tomorrow. And then we're on our last couple days of pre-cal.